In our type of reactors, it just generates more and more fuel out of thorium, because our reactors is what is called a breeder reactor that can generate more fuel than it consumes. So actually you end up in a situation where you just generate more and more and more fuel over the years. Of course, it's not fast. It takes decades to generate more fuel, but at least you don't waste all the fuel. You actually end up with more than where you started.
Yeah, amazing. Just quickly on the safety features in terms of shutdowns and operations, just what's the concept and how are you going to do that?
Yeah, so it's actually super simple. So for traditional nuclear reactors, you have something called shutdown rods, or different types of rods that you insert into the reactor to make the chain reaction stop. And maybe in the movie about Chernobyl, you've seen some of these and how they had an issue in the way they were designed. But for a molten salt reactors like ours, it's completely different, because as soon as you remove the fuel salt from that onion core, the chain reactions stop immediately. And it's not like all of it has to be removed. As soon as you just remove a few liters of fuel, then the chain reaction stops. And we do that. So the way our reactor works is that we pump salt and heavy water up into the core. So all the time when the pumps are running, they pump salt into the core. But as soon as you stop the pumps, the chain reaction stops immediately. And then, of course, when you stop the pumps, everything is draining down into a drain tank. And some other designs of molten salt reactors, they use what is called a freeze plug. And the first reactor that was built in the 1960s also used this freeze plug. But we don't need that because of the way we have designed our reactor, and we're not the only ones. There's actually other companies doing the same. But we just, as long as the pumps are running, salt and water is pumped into the core, and then when you cut the electricity to the pumps, then automatically everything drains into drain tanks and the reaction stops, and it's in a safe state, even if there was like bombs falling or or earthquake or whatever might happen. So that's also why in the control room we just have a stop button, and the person in this control room can just press stop button, and then it cuts the power to the pumps and everything drains. Or if there is an explosion or something and the electricity supply stops, then also it will put itself into a safe state. So even if the humans are not there, it will still stop and get into a safe state. Because actually we never expect that any humans will hit the stop button. We expect that the control system would be able to shut down, many milliseconds before the human can even start moving their hand. So it will
Wow.
likely never be possible for a human to hit the stop button before the reactor's already stopped itself.
Yeah, it's like what I'm excited about this is that we are getting into an age of this new nuclear age where it's almost like the planes are more you're more safer to be in a plane than being in a car.
Yes.
It's that we're getting to that stage, which is what's very, very exciting about this. So thank you very much for taking me through the reactor. Wow, it's I'm pumped. I'm so excited. So I want to move on. I want to talk about your business model. I want to talk about your customers and how they would be interacting with you in the future. The first thing that kind of really stood to me is this concept of nuclear as a service. I think I'm going to get that printed on a T-shirt and wear that proudly because I love that concept.